increasing globalization of the world, people often have a hard time communicating due to language barriers. Imagine facing this problem every single day and you'll understand what it's like for the deaf and mute. Up to 1 million people in the United States use American Sign Language, or ASL, as their primary method of communication. This problem has not been properly addressed. Thus, we have created Muse to bridge the communication gap between users and non-users alike.
To determine placement of the electrodes for optimal muscle activity, we reviewed literature and found that the highest activity was located on the flexor digitorum superficialis, the extensor carpi ulnaris, and the flexor carpi radialis.
Muse consists of an Arduino Mega microcontroller, 4 Olimex electromyography shields, and an inertial measurement unit, all of which are connected to electrodes that detect electromyography signals produced from muscle contractions in the arm. This process begins when the user begins to sign in ASL. Hand contractions create EMG signals, and changes in arm orientation is sensed by the IMU. This data is detected using the Arduino Tower and sent to the computer for processing via serial communication with MATLAB. Within MATLAB, incoming data is compared with the standard of each letter using a correlation function. MATLAB then outputs audio corresponding to the signed letter.
Muse currently translates the entirety of the ASL alphabet and some daily phrases. Through a series of EMG test trials, we have determined signal standards for each letter of the alphabet. These standards are then correlated with the user's EMG data. We then use these correlations to identify the sign. Now we will perform a short demonstration of Muse. After signing the letter, the signals produced are then processed and then translated into audible sound.
E F M